You're sitting in a meeting, completely normal Tuesday. Someone puts a photo on the projector, stock image meant to illustrate something about supply chain logistics, and there's a spider in the corner of the frame. Irrelevant. Not even the point of the slide. And your entire nervous system detonates. Your stomach drops like an elevator with a cut cable. Your palms go wet. Your throat does that thing where it forgets how to be a throat. You're not in danger. Everyone else in the room is looking at pie charts. But your brain has already filed its verdict, signed the paperwork, and sent your body into full catastrophic response, all in roughly 12 milliseconds. Here's what nobody tells you. Your phobia isn't a personality flaw. It's not weakness. It's not something you can logic your way out of by reminding yourself that spiders are small and you are large. It's a hardware-level rewrite, and understanding exactly how that rewrite happens is the only way you ever stop being ambushed by a PowerPoint slide. Let's start with the crime scene. Your amygdala, two almond-shaped clusters buried deep in your temporal lobes, is not your fear center in the way a smoke detector is a fire center. It doesn't just detect threat, it coordinates the entire emergency response. Your muscles locking up, your hormones spiking, your prefrontal cortex getting effectively locked in a supply closet, while the alarm system runs the building. When researchers destroy the amygdala in rats before fear training, the animals won't freeze, won't vocalize, won't spike their stress hormones, even when the situation objectively demands it. The whole orchestra needs a conductor. Yours is the amygdala, and it is very, very good at its job. The problem is what happens when it learns something wrong. Here's the moment a phobia is born. You encounter something. A dog, a height, a needle, a crowd. Your senses relay that information to your amygdala via two routes simultaneously. A fast, crude signal from the thalamus that arrives in milliseconds, and a slower, detailed signal from your cortex that takes a fraction of a second longer. That fast thalamic signal is a blurry snapshot. It doesn't know if the dog is friendly or rabid. It doesn't care. It fires first and asks questions never. And when that signal arrives paired with something frightening, real pain, real danger, or even just overwhelming shock, something happens in the synaptic connections of your amygdala that neuroscientists call long-term potentiation. Think of it as your brain carving a groove into wet concrete. Glutamate floods the synapse. Postsynaptic membranes depolarize. A protein called REB gets phosphorylated inside the neuron, which triggers gene expression, which triggers protein synthesis, which physically grows new dendritic spines on the lateral amygdala neurons. Your fear memory doesn't get stored like a file on a hard drive. It gets built into the architecture. The neuron literally reshapes itself around the experience. One bad encounter with a dog when you're 4 years old, and your amygdala has now constructed a structural monument to that moment. Congratulations. You have a phobia. The wet concrete is now stone. But here's where it gets genuinely interesting, and also where the popular story completely falls apart, because you didn't have to actually experience anything. Some phobias arrive without a single traumatic event. You've never been bitten by a spider. You've never fallen from a height. You've never had a bad experience with open water. And yet the sight of any of these things sends ice water down your spine and makes your vision tunnel at the edges. This isn't learned fear. This is something older and stranger, innate amygdala sensitization. Your right amygdala, specifically, shows long-lasting enhancement of neural transmission for certain threat categories: predators, heights, contamination, independent of personal history. Your brain came preloaded with some fears before you ever had the chance to earn them. Evolution didn't trust you to figure out that snakes were dangerous on your own. It just hardwired the conclusion and skipped the lesson. You inherited a verdict without a trial. Now enter norepinephrine, your brain's emergency broadcast signal. When something frightening hits your amygdala, norepinephrine floods in and does something counterintuitive. It stimulates inhibitory neurons inside the amygdala itself, which produce repetitive bursting electrical patterns, shifting your brain waves from a calm resting state into a high arousal pattern that's specifically optimized for fear memory formation. Your brain is essentially saying, whatever is happening right now is important. Encode it permanently. The norepinephrine isn't creating the fear. It's laminating it. It's pressing the memory into your neural tissue with the full force of your stress response, making sure it never fades. Every subsequent exposure to the trigger reactivates this system, relaminates the memory, and makes it harder to undo. Your amygdala doesn't just remember the spider, it remembers it louder every time, which is why avoiding the thing you fear is the worst possible strategy. And here's the piece of neuroscience that should genuinely disturb you. The cells doing some of this work aren't even neurons. Astrocytes, the cells that were written off for 150 years as structural filler, the brain's packing peanuts, are actively contributing to the formation of aversive fear memories, not supporting the neurons doing the work. Doing the work. Parallel processing. Your phobia is being maintained by cells your biology textbook told you were glorified scaffolding. Neuroscience has had to revise its entire understanding of what a fear memory even is. If that doesn't make you feel slightly betrayed by science, check your pulse. So why can't you just decide to stop being afraid? Your ventromedial prefrontal cortex, the part of your thinking brain that handles context, safety signals, and the crucial information that the spider in the meeting room is behind glass on a projector, is supposed to inhibit your amygdala by activating GABAergic interneurons inside it. GABA is your brain's brake fluid. When the VMPFC works correctly, it sends the signal. This is not a real threat. Stand down. The amygdala's brakes engage. You feel the spike of fear, and then it fades. But in phobia, this braking system is underperforming. The GABAergic inhibition is too weak, too slow, or too easily overwhelmed by the amygdala's established structural response. Your prefrontal cortex is filing the paperwork to override the alarm, and the alarm isn't reading its memos. Reason cannot outrun architecture. The only thing that actually works, and the research on this is unambiguous, is graduated, repeated exposure in contexts where nothing bad happens. Not because you're teaching yourself courage, because you're triggering a competing neurological process called extinction, where the VMPFC slowly, effortfully rebuilds its GABAergic connection to the amygdala through repetition. Imagine yourself in a room with the thing you fear. At a distance so manageable, your fear response stays at a low hum rather than a full alarm. Nothing happens. Your brain reluctantly updates its prediction. You move slightly closer. You stay again. Each session is your VMPFC doing one slow, grinding rep in the gym, building the inhibitory pathway one increment at a time. It's not fast. It's not comfortable. But it's the only process that physically rewires the structure your fear is built into. There's also something remarkable happening in your visual cortex. Research on animals learning to suppress instinctive fears reveals a region called the ventrolateral geniculate nucleus, a way station in the visual processing pathway, that stores suppression memories using endocannabinoids, your brain's own cannabis-like molecules, to quiet the fear signal before it even fully forms. Your brain has a built-in fear suppression mechanism that operates below conscious awareness, and it can be trained. The visual cortex needs to write the lesson first, but once it's written, the suppression persists even when the cortex is taken offline. You can learn to not react, and that learning can outlast the conscious effort required to learn it. Your fear is a structural fact. Your brain encoded it in stone, laminated it with stress hormones, and had the audacity to use cells you didn't even know were involved. But stone can be worn down, not by telling it to be sand, but by the slow, patient, unglamorous pressure of returning to the thing that terrifies you and surviving it, again and again, until your brain's own architecture shifts beneath you. You don't overcome a phobia by being brave. You overcome it by giving your prefrontal cortex enough reps to finally outbuild what your amygdala spent years constructing.